Okay, this is the third video in a series of how you solve simultaneous equations for the Mathematics Advanced course in 2019, sorry, new course. So we've done this and we've done this. So we're now looking at the three unknowns. So it's just for three unknowns you need to have three equations. So that's what this is really about. We're not going to involve nonlinear things as well, because then you end up with multiple answers. As it is, of course, you end up with three values for each group of answers, an x, a y, and a z in this case. Now, I guess I've left a little space here because I'm happy to have a bit of a method, and the method is eliminate x, y, or z from two different pairs of equations. In other words, you create, if you eliminate, say, z, you create down here somewhere two equations and two unknowns, which we're more familiar with solving. So I'm only going to do one example, and then hopefully you can work through some questions. So looking at this is a particular question with three equations and three unknowns, x, y, z, three equations, 1, 2, 3. So that should have a clear answer. It should have one answer. If I only had two equations two equations with three unknowns, it's got an infinite number of answers. By having three equations, suddenly it locks it down to having only one, not pair, but one group of three answers that make it work. Now, you just got to spend a bit of time to begin with looking, can you eliminate x and y or y and z in one go? Because occasionally that might happen. I haven't really looked at the textbook questions. Have a quick look. Yeah, some of them actually have got an x value or an a value given straight away. So in fact, you can do it different to this. You just sub that value into the others to get rid of the x or the a. Now, I can't get rid of x. I can get rid of x here. I can't get rid of y. I can get rid of x, but I can't get rid of z. I can get rid of z, but I can't get rid of x. So there's no way here of trying to eliminate two things at the same time. If this was a plus, then you'd have a plus x and a plus z. You could minus them and it would eliminate them in one go. Now, because you can't do it in one go, you've got to do this. Eliminate x, y, or z from two pairs of equations. And for this particular one, you can see z, minus z, minus z. They're the most similar. So I'm going to get rid of z's first. The x's, there's two x's here, sure. There's two y's here, but they're in different equations. So that won't get rid of x or y or z in one go, but this will. So let's get rid of the z's. So I'm going to add 1 and 2. If I add 1 and 2, it will go minus z plus z. They will disappear. I'll get 2x minus y plus 2y is plus y equals, and then this disappears on this side, minus positive 3, when you add them together. I'm going to call that equation 4. Now, I need to get rid of z in another pair of equations. So I'm either going to use these ones or these ones, 1 and 3 or 2 and 3. I like adding, so I'm going to go 1 and 3. I'm going to add them together, and that will get rid of z separately. 1 plus 3. That will give me 4x minus y is minus 2y plus z minus z is no z's equals 10. And that's equation 5. So now I've got, if you look at it, two equations in two unknowns, x and y, x and y. In other words, we've created exactly what the first lot of exercises we did was all about. All right, so now let's just do what we did before. I want to get rid of the x's or the y's. So I would get rid of either. It doesn't make much difference. You could double this one and subtract them to get rid of the x's, or you can double this one and add them and you get rid of the y's. I'm going to do that. 4. So I'm going to go 4 times 2. That means it'll give me this one, 4x plus 2y equals 6. Don't forget to add, if you're timesing by 2, times everything by 2, including the right-hand side. Now, I'm going to work with these two. Plus 2y minus 2y. I'm going to add them together. 5 plus 6. 5 plus 6. That's going to give me 8x, minus 2y plus 2y is no y's. And 16. That's not an equation 7 because this is just giving us an answer. X equals 2. Nice answer. It's always nicer when they're not fractions. Sometimes they are fractions though. Okay, next I need to get what y is. I'm going to stick to these two equations. I'm not going back up here yet because up there I don't know what z is and I don't know what y is. But here, I can use one of these. I'll use this one, I think. Just sub in what x is, and it'll tell me what y is. So sub x equals 2 into equation 4. So you get 2 times 2, so that's 4, plus y equals 3. Rewriting this one with x equals 2 in it. And that gives you a nice answer too. Y equals minus 1. So once you've got x and once you've got y, you just need then to find out what z is. And you've got x is 2, y equals minus 1. You can sub it into any of these and we'll tell you what z is. So I'm going to sub it into equation 1. Sub x equals 2, y equals minus 1 into equation 1. And I will get, can you see? Yeah, you can see it. 2 instead of x minus 1 instead of y plus z equals 7. So 2 minus 1 is 2 plus 1, so that is 3. So z is 4. Let's have a quick look at the answers. Check it. Is 2 minus 1, 3, plus 4 equals 7. Yes, it works with that one. Is 2 plus 2 times minus 1 is minus 2. So is 2 minus 2, 0. Minus 4, yes. And is 3 times 2, that's 6. Plus 1, because it's minus 1, so that's 7. Minus 4 is 4. Good news, because it means we've got it. These are the 3 answers. X equals 2, y equals minus 1, z equals 4. It's actually one answer, because this corresponds, if you had an x, y, and z number plane, which we don't even worry about at high school, x, y, z, this would correspond to one point where 3 lines meet. So that's it. I want you to work on exercise 2.12, doing, again, the old ones, which are 1, 3, 5, 7, 9. Good luck.